Today we're talking about lesson 3.11, module 3, lesson 11. And your learning goal today is to be able to subtract fractions by making equivalent fractions. We learned how to add fractions using equivalent fractions, and then we learned how to add fractions where their sums are going to be bigger than 2. So today let's look at subtracting fractions by using equivalent fractions. When we're faced with a subtraction problem, we have to also check if we're ready to subtract. In this case, are we ready to subtract? No, why not? Everyone? Yeah, the denominators are different. So we, again, need to find the LCD. In this case, looking at our two denominators of 3 and 5, what do you think our LCD, or least common denominator, might be, Sporty? 15. Okay, let's do some multiplying. We can say 1/3 times some version of 1 will give us the LCD of 15. What version of 1 should I multiply 1/3 by? Michael? 5/5. Yeah, that's a good version of 1. Okay. And then we're going to, oops, we're not adding. We have to be careful. We're subtracting 1/5. What version of 1 should I multiply 1/5 by to get the LCD of 15? Aditya?
You need to multiply by
3/3. Okay. Now let's multiply. 1 times 5 is? 5. 3 times 5 is 15, of course, our LCD. 1 times 3 is?
5.
1 times 3 is 3. 5 times 3 is 15. Now we have 5/15 minus 3/15. Does that have the same value as our original problem?
Yes.
How do we know it has the same value as our original problem? Sonia?
Because we were multiplying by 1.
Right, we multiplied each number 1/3 and 1/5 by 1. They look different, but they're different versions of 1. Remember, 1 is like ditto. It can change shapes, change forms. So when we multiply something by 1, does it change its value?
No.
So when I multiplied 1/3 by 5/5, is its value still 1/3? And when I multiplied 1/5 by 3/3, is its value still 1/5? So is this 5/15 minus 3/15, does that have the same value as my original problem? The only difference is now the denominators are the same, which allows us to subtract. So if I have 5/15 and I take away 3 of those 15s, how many 15s do I have left? 2 15s. Therefore, and is that in simplest form? Good. Therefore, 1/3 minus 1/5 is 2 15s. Instead of having a fraction subtracted from a fraction, we might have a fraction subtracted from a mixed number. Okay? Now, when you are approached with mixed numbers, you have two methods of dealing with this. We're going to talk about one method at a time. The first method is labeled method 1. Okay? And here you can see I separated 1 from the 3/4. Do you guys see that? I said 1 and 3/4 is the same thing as 1 plus 3/4. Do you agree? And then I kept the minus 3/5 right here. I know that 1 is the same as 4/4. So therefore, 1 plus 3/4 is the same thing as 4/4 plus 3/4, which is 7/4. So this is the same thing as 7/4 minus 3/5. Yes? And then when I get to this point, what do we call this first number? What kind of fraction? Improper fraction. So I'm basically changing my mixed number into an improper fraction. And now I can subtract like I normally would. What I would do is I would find the least common denominator, which is?
20.
Yep, it's 20. Good. So then I could do 7/4 times 5/5 minus 3/5 times 4/4 to get 35/20 minus 12/20, which equals 13, right? No, 23. Yeah, 23/20, which is the same as 1 and 3/20. Yes? Okay. Now, method 2 is a little bit different. We don't use the improper fraction. Okay? Oh, man. Well, that's very confusing. Okay. We're just going to look. Method 2 is this part right here. Okay, let's look in the box here. Here, I did separate it out, but then what I did was I changed the fraction part. I kept the 1 by itself, and I changed the fraction part. So I had 1 plus 3/4 Do you guys see that right here? Then I only took the 3/4 part and the 3/5 part and changed those to my common denominator of 20. Then I had 1 plus 15/20 minus 12/20. I can do this part first, can't I? What's 15/20 minus 12/20? 3/20. And if I don't forget the whole number, I would get the same answer of 1 and 3/20. Does that make sense? Okay, so there's two methods. We're going to try both today. So remember, method 1, we change the mixed numbers into improper fractions. So we can say that 5 and 3/4 is the same as 5 plus what? 3/4. And we have to put that in parentheses to show that those go together. And from that, we're going to subtract, in parentheses, 3 plus 1/6. It's important to put these parentheses because we need to show that the 3 and the 1/6 go together and the 5 and 3/4 go together, and we have to put them together before we can subtract. Okay, if we don't, we're going to subtract the 3 before we add the 1/6, right, according to the order of operations. So we need the parentheses. Okay, now if I have 5, is that the same as 1 plus 1 plus 1 plus 1 plus 1? You guys agree that that's 5?
Yes.
And then I have to add the 3/4, right? And then over here, if I have 3, I have 1 plus 1 plus 1 plus 1/6. Yes? Okay. Now, how many fourths is equal to 1? 4. So is this the same as 4/4 plus 4/4 plus 4/4 plus 4/4 plus 4/4 plus 3/4? Is that the same thing? Right? Because I have 1, 2, 3, 4, 5 plus 3/4. And over here, I have 6/6 plus 6/6 plus 6/6 plus 1/6. Yes? Okay. Now we're ready to add because over here, I only have the denominator of 4. So what's 4 plus 4 plus 4 plus 4 plus 4? Huh? 20 plus 3?
23.
So over here, how many fourths do I have altogether?
23.
Okay, so my new problem is 20, or my new way of writing it is 23/4. And then over here I have 6 plus 6, 6/6 plus 6/6 plus 6/6 plus 1/6. So what's 6 plus 6 plus 6?
18.
Plus 1? So how many 6 do I have altogether here?
19.
19/6. So now I've rewritten my mixed numbers 5 and 3/4 and 3 and 1/6 as improper fractions, 23/4 and 19/6. Now all I need to do is treat them like normal fractions and solve. So what would my least common denominator be for 4 and 6? Junebuk? 12. Good. My LCD is 12. So let's see. 23/4 times what version of 1 will give me a denominator of 12? Sporty? 3/3. Good. Okay. And 19/6 multiplied by some version of 1 will give me a denominator of 12. What version of 1 am I looking for, Ben? My LCD is 2 halves. Good. Okay, so now we can multiply. What's 23 times 3?
69.
69/12. Good. What's 19 times 2? 38/12. Good. Okay, so if I have 69/12 and I take away 38 of them, how many do I have left? Lakshan?
35.
What's 60 minus 30?
30.
What's 9 minus 8? 31/12. Good. Now, is that in simplest form?
No.
No, we need to simplify it because that's an improper fraction. So how many wholes are there in 31 12ths? 2. Okay. And if I take away 24 from 31, how many 12ths do I have left? 7/12. So the answer should be 2 and 7/12. Let's try and see if we can do method 2. Let's see if we can separate out 5 minus 3 minus 3/4 minus 1/6. Is there a commutative property of subtraction? No. So let's see if this works. 5 minus 3 is 2 minus 3/4 minus 1/6. Okay. Now let's try to find the LCD. What would the LCD be of 4 and 6? 12, right? 12. So we would do 2 minus 3/4 times 3/3 minus 1/6 times 2 halves. Okay? 2 minus 9/12 minus 2/12. Oh. So over here, we can do the whole number part first, and then, so subtract the whole number part, and then subtract the fraction part. But the important thing to remember is when we have mixed numbers, we add the whole number part to the fraction part. Okay? So what's 9/12 minus 2/12?
7/12.
Yeah, so then our answer is 2 and 7/12. Is that the same answer? Okay. So again, there's two different methods for solving these problems. You can choose which method makes the most sense to you.